All right, so this is your introduction to linear correlation. There's really no math in this video, it's all just information. So correlation by definition is just a relationship between two variables. We show that things are related. That is all this does. So when we're talking about a positive correlation, if we think about a graph, a positive correlation is where the data follows a positive trend, and a negative correlation is where it follows a negative trend. So when you think about a scatter plot with a positive trend, well, then it's going to have a positive correlation. It simply means that as one thing increases, the other also increases. Now, the closer the dots are to a line, the stronger the correlation. So if I have dots that are really close to this line, we would say there's a super strong correlation. Well, maybe not super strong, but there's a strong positive correlation. If my dots are out, okay, hold on, let me get rid of this line. If my dots are, they're really far away from this line, well, then we would say there's a weak positive correlation. So it really depends. The closer your dots are to this actual line, the stronger the relationship, right? It's just a relationship. Shows that the two variables, the x and the y-axis, are actually related. So when you're looking at your dots, okay, so first off, if we just look at up here in this blue area, you can see that we have, just random scatter plots. And you can kind of think of these as, on ordered graphics here. And then you can say, well, if you look down, if we have this set of spots, we can draw a trend line right through there. And you can see these dots are really close to the line, so it's strong and it's positive. It's positive because our graph is going up. Now, in the second one, the dots are a little bit farther away from the line, so we have a moderate positive correlation. If the dots would be even further out, we would call that then weak. All right. The middle one doesn't really show that it's going up. These dots are all over the place. This is like if maybe we were doing shoe size and eye color, right? There is no relationship between shoe size and eye color, so those dots would just be all over the place. Now, when we go over yonder, you can see we have a moderate negative and a strong negative. It's just negative because our graphs are going down as we look left to right. That's what makes them negative. So when we're looking at this is super important. Correlation is a mathematical relationship and does not imply causation. So just because two things show they are related does not mean that one causes the other. I read an article that there was a correlation between getting tangled in your bed sheets and dying from like ice cream poisoning or something. Just because there was correlation when you graphed those, two random stupid things, that does not mean that one is causing the other. It doesn't mean that if you get tangled in your bed sheets tonight, you're going to die from ice cream poisoning tomorrow or something equally as crazy. All right, so it's correlation means a relationship, not one causing the other. So correlation with a relationship, these are some examples. Time spent studying for a test and your test scores, that's a relationship. The number of appliances in the home and the cost of an electric bill. That's a relationship. Alcoholism and smoking. Relationship. Weight of the vehicle and gasoline usage. Relationship. These are all correlation. Now the causation, the cause and effect, if you take a test, you're going to earn points. You take the test, you earn points. That's a cause and effect type of thing. If you don't pay your bill, you will not have electricity. Cause and effect. If you smoke, your potential for lung cancer. Cause and effect. Cost of barrel of oil and gasoline, cause and effect. As oil prices go up, gasoline prices go up. So you can see the difference between correlation and causation. Very, very huge. But correlation is simply a mathematical relationship and does not imply causation.